Hello and welcome to this video. In this video, we will solve ninth set of complex number problems, that is problem number 81 to 90. So as I always say that you should pause the video when I state the problem and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further ado, let's get started. Problem 81 says that if z to the power 4 plus z cube plus 2z square plus z plus 1 is equal to 0, then prove that mod of z is equal to 1. So we split this z square into 2 and then we take z square common from first three terms. What we will have in brackets is z square plus z plus 1, and what will be left with is z square plus z plus 1 is equal to 0. Now if you take z square plus z plus 1 common from both, you will have z square plus 1 into z square plus z plus 1 is equal to 0. If z square plus 1 is equal to 0, then z is equal to I, which implies that mod of z would be 1. Now, if z square plus z plus 1 is equal to 0, then z is cube root of unity, that is omega and omega square. So mod of z is 1 in this case as well. Problem 82 says that if z is 7th root of minus 1, then find the value of z to the power 86 plus z to the power 175 plus z to the power 289. So since z is 7th root of minus 1, so we can say that z to the power 7 is minus 1. Now we can write 86 as 84 plus 2, and 84 is 7 into 14. So it is z to the power 7 into 14 plus into z square. 175 is 25 into 7, so z to the power 7 into 25. And z to the power 289 is 287 plus 2. 287 is 7 into 41. So z to the power 7 into 41 into z square. Now we substitute minus 1 for z to the power 7 here. So minus 1 to the power 14 is plus 1. So eventually this is z square. Here we put minus 1, then this minus 1 to the power 25 is minus 1. And here it is minus 1 to the power 41, which is odd. So it would be minus 1 into z square, that is minus z square. Now z square will get cancelled, and what will be the result is minus 1. Problem 83 says that if z cube plus 2z square plus 3z plus 2 is equal to 0, then find all the non-real complex roots of this equation. So we write this equation as z cube plus z square plus 2z and z square plus z plus 2. So again we take z square common from first three terms, we will be left with z square. You take z common, then it will be left with z square plus z plus 2. So you take z square plus z plus 2 common again, you will have another product in the term z plus 1 is equal to 0. Now if z plus 1 is equal to 0, then z is minus 1, which is real and is useless for us in this case. But if z square plus z plus 2 is equal to 0, then z is equal to minus 1 plus minus actually the square root I square root of 7 by 2, which are complex roots of the given equation. There is a typo, there should be a minus sign here, plus minus sign. Problem 84 says that if z is a non-real root of z is equal to 5th root of 1, then find the value of 2 to the power 1 plus z square plus z to the power minus 2 minus z to the power minus 1. So since it is 5th root of 1, that is z is 5th root of 1, we can say that z to the power 5 is equal to 1. Now here we can write z to the power minus 2 as z cube and z to the power minus 1 is equal to z4, because this is 5. Z to the power 5 is 1, so z to the power minus 1 is z to the power 5 by z is equal to z4. And similarly z to the power minus 2 is z cube. Now we add z to the power 4 and subtract also, so we get 1 plus z square plus z cube plus z to the power 4 minus 2z to the power 4. So once we have this is a geometric progression 1 to z to the power 4, which is sum would be equal to 1 minus z to the power 5 by 1 minus z. Now z to the power 5 is 1, so this term will become 0. So this whole thing is 2 to the power minus 2z4, that is 2 to the power square, because mod of z would be 1. So mod of z4 will also be 1. So the end result is 4. Problem 85 says that if z is a non-real root of unity, then find the value of 1 plus 3z plus 5z square plus up to 2n minus 1 z to the power n minus 1. So we let s is equal to given sum, and then we multiply it with z. So it becomes z plus 3z square plus 5z cube up to 2n minus 1 z to the power n. Then we subtract. So 1 will be here, and 3z minus z would be 2z, and 5z square minus 3z square will be 2z square, and so on up to 2z to the power n minus 1 plus 2n minus 1 z to the power n. So now we have this one, and z to the power n would be 1. So this 2n minus 1 we write here. So 1 will cancel each other. 2 ones will cancel each other, and this is 2z to the power 2z up to 2z to the power n minus 1. We take 2 common, and what we will have is z plus z square plus up to z to the power n minus 1. So since z to the power n is equal to 1, so sum of all these roots would be 1. Let me think. So no, this is wrong actually. This would be minus 2 actually. Yeah, because 1 plus z square up to z to the power n minus 1 would be 0. So this would be minus 1. Yeah, it is correct. So for example, if you have say cube root of unity, so when z is equal to cube root of unity, 1 plus z square is 0. So similarly for nth root of unity, 1 plus z square plus up to z to the power n minus 1 would be 0. So z plus z square plus up to z to the power n would be n minus 1 would be minus 1. So you multiply that with 2, you get 2n minus 2. So s would be 2 into n minus 1 by 1 minus z. Problem 86 says that find the value of square root of minus 1 minus square root of minus 1 minus square root of minus 1 and so on up to infinity. So in this case, we let the given expression to be z. So we can write that z is equal to square root of minus 1 minus z. We square and bring everything on one side, we get z square plus z plus 1 is equal to 0. So you know that this is an equation which will give us cube root of unity, that is omega and omega square. Problem 87 says that if z is equal to e to the power I into 2 pi by n, then find the value of 11 minus z into 11 minus z square in up to 11 minus z to the power n minus 1. So given z is nth root of unity, since it is nth root of unity, we can consider an equation x to the power n minus 1, which we can write as x minus 1 into x minus z up to x to minus z to the power n minus 1, where z is a root, 1 z square, z cube are roots of this equation x to the power n minus 1. Now it's a simple matter of substituting x is equal to 11, and then you have the end result as 11 to the power n minus 1 by 10, because this whole thing is equal to 11 to the power n minus 1. So you divide with this x minus 1, that is 11 minus 1, that is 10. So that's how we arrive at the desired result. Problem 88 says that if 3 by 2 plus cos theta plus I sin theta is equal to a plus b, then prove that a square plus b square is equal to 4a minus 3. So what we do is we rationalize this, and there should be an equal sign here. We rationalize this, that means we multiply with complex conjugate of denominator, so we get this fraction as 3 into 2 plus cos theta minus I sin theta by 5 plus 4 cos theta. Then we compare real and imaginary parts. We get a is equal to 6 plus 3 cos theta, because 3 into 2 is 6 and 3 into cos theta is 3 cos theta. And b would be minus 3 sin theta by 5 plus 4 cos theta. Now we simply evaluate a square plus b square. So 6 plus 3 cos theta square will be 36 plus 36 cos theta plus 9 cos square theta. And minus 3 sin theta square would be 9 sin square theta. The denominator would be same for both, that is 5 plus 4 cos theta whole square. Now 9 sin square theta plus 9 cos square theta is 9. And 9 plus 36 is 45. So 45 plus 36 cos theta. We take 9 common, we get 5 plus 4 cos theta in the brackets. We cancel one power, and we get the result as 9 by 5 plus 4 cos theta. Now we calculate 4a minus 3. So 4 into 6, 24, and 4 into 3 cos theta is 12 cos theta. Now minus 3 when multiplied with denominator will become 15 minus 12 cos theta. 12 cos theta gets cancelled. 24 minus 15 is 9 by 5 plus 4 cos theta, which is equal to a square plus b square. Problem 89 says that if 2z mod of 2z minus 1 is equal to mod of z minus 2, then prove that mod z is equal to 1. So we let z is equal to x plus iy. So the given equation becomes mod of 2x minus 1 plus 2iy is equal to x minus 2 plus iy. We square both sides, we get 4x square minus 4x plus 1 plus 4y square is equal to x square minus 4x plus 4 plus y square. So 4x will get cancelled. This x square goes left side. It becomes 3x square. 4y square becomes 3y square when subtracted with this y square. And 4 minus 1 is 3. So 3x square plus 3y square is equal to 3. That is x square plus y square is equal to 1. So mod of z is equal to 1. Problem 90 says that if x is real and 1 minus ix by 1 plus ix is equal to m plus in, then prove that m square plus n square is equal to 1. So we are given this equation, we rationalize by multiplying and dividing with complex conjugate of denominator. We get 1 minus ix whole square by 1 plus x square. That becomes 1 minus x square minus 2ix by 1 plus x square. We compare real and imaginary parts. We get m is equal to 1 minus x square by 1 plus x square, and n is equal to minus 2x by 1 plus x square. So m square plus n square will be 1 minus x square whole square plus 4x square by 1 plus x square whole square. Now 1 minus x square whole square would be 1 minus 2x square plus x to the power 4. And when you add the 4x square to that, it becomes 1 plus 2x square plus x to the power 4, which is equal to 1 plus x square whole square. And you cancel them. That is numerator and denominator, you will get 1. So with this, we come to the end of 9th set of problems on complex numbers. In the next video, we will solve the next 10 problems, that is the 10th set. I hope that you have found this video useful. So please subscribe to the channel and like the video so that it can reach many other students like you and benefit them as well. So I'll see you in the next video. Enjoy.